Good morning, everyone. Welcome to the STEM Digital School. This is grade 6, Natural Sciences and Technology. Right, guys, we are going to continue from where we left off yesterday. Just quick reminder of the ground rules. Please do not switch on your videos during class. And you guys can raise your hand if you want to answer or ask a question. And you can also use the group chat for that purpose as well. Okay, so if at any point of the lesson I am going too fast, you can just indicate for me using those buttons at the participants icon. All right. Um, Morning, Kia. Morning, Mukona. Hi, guys. Hi, guys. Okay, let's get into the lesson. Hi, Kia. We've just started and I should go slower. Okay. Okay. All right. Cool. Yeah, okay, so this week, guys, we have been looking at electric circuits. Okay, so or rather, we started doing electric circuits. Remember, this is under the topic of energy and change, and it's term three's work. Okay, so it is term three's work. If it is the first time you're joining us, then you can just turn into your textbooks by energy and change, and we're doing electric circuits. All right, so we're just gonna wrap up electric circuits and then move on to electrical conductors as well as insulators. Okay, so what we have already learned, okay, up till this point, is that unlike charges attract and like charges repel each other. Okay, and we also learned the difference between a cell and a battery. Okay, and we also looked at electrical components, and this was yesterday. Okay, so let's just go through it again. We said that the parts that make up an electrical circuit are known as electrical components. Components like a cell or battery that make charges move, these are known as input devices. Then we also said that components like switches that control the flow of charge inside a circuit are known as process devices because they change the current or the electric current in some way. Guys, videos off. Thank you. Components like bulbs, buzzers, or motors, these change the electrical energy into useful energy, and these are known as output devices. They are the components that use the electrical energy to do something with. All right. Then we also looked at conducting wires, which join other components together in a circuit. Okay. Right, and we looked at an example of a simple circuit. And I did tell you guys yesterday that you will be required to build a simple circuit at home. So I will put up the instructions for the project or the activity up on the website. Right, so then you guys can download the instructions as well as the activity on the website. All right, so this will be for like Monday and Tuesday, Monday or Tuesday. Okay. So I'll just confirm with you guys tomorrow. Right, and we looked at an electric circuit, right? I think this is where we kind of stopped. We looked at the electric circuit, and I told you guys that this can be drawn dramatically, okay? So we can draw a circuit diagram to basically show us how the electric circuit that we built looks like. And here is an example of that circuit diagram, all right? So what we have learned so far in this is just a quick summary, is that an electric circuit needs to be closed, otherwise charges will not flow. Remember, I said that is a very important point. I also mentioned that this means that there should be a continuous path for charges to flow through. And then if there is a break in a circuit, charges will not flow. And remember, guys, a break in a circuit might be caused by a switch or might be caused by if we don't have a conducting wire at some point. All right, and then a switch controls the current. It can switch the current on or off. A simple circuit will work no matter where the switch is placed. All right. Okay, then we get to the business of today, which is circuit diagrams. First bullet reads, if we want to keep a record of how we constructed a specific electric circuit, we can take a photo of it. If we do not have a camera, we can remember the circuit by drawing a sketch. Okay, so here we have a diagram, or rather a circuit which was built as a sketch of a simple circuit with a paperclip, switch, and battery, as well as bulb. But guys, now it becomes really difficult. Now, imagine now you have built your own circuit and now you are supposed to draw it, right? You're supposed to show it to me in a picture. It's going to be really difficult because not all of us can draw very well, all right? So that is why we have resorted to using symbols, okay, to represent certain components of the circuit, okay? And we come up with these sketches as well as symbols. So very important to note, you guys should know all these symbols, right, and know what they represent. Okay, so here we have a battery, right, or a cell, and this is how a battery, or rather this is the symbol of the battery. We have an indication of the positive end as well as the negative end. So the longest strand is the positive end and the shortest strand is the negative end. So you guys can just quickly write this in your book. Okay, it's very important. The bulb, it is indicated by this particular symbol here. So instead of drawing the whole light bulb, we just draw the circle with a X in it. Okay, here I see your hand. I will come to you now. Then we have electrical wire. All right. So guys, very important to note that if you are going to draw electrical wires in a circuit diagram, you need to use straight lines. Okay, we use straight lines. Your lines should not be curly or curving or anything like that. Straight lines and sharp corners. Okay, so electrical wires just indicated by straight lines. Then we have a switch. So a switch, this is the symbol of a switch, and as you can see the top part here, that indicates an open switch, all right? So when the line is on top and when they are not together touching, that means it's an open switch, okay? And then a closed switch is indicated by these two dots that are closed, all right? So you guys should know the symbol of each component. Okay, so I'll give you guys time to draw that in your book. Okay, yeah.
Hello, ma'am.
Hello.
How are you?
I'm well, thanks. Yourself?
I'm good. I wanted to ask, when are we gonna write the test?
Okay, so the test is tomorrow. Okay, it's for tomorrow, and you're
Okay,
gonna do
ma'am.
it after
Thank
school.
you.
Okay, cool.
Okay,
So
ma'am.
guys,
Thank you, ma'am.
sure. Right, guys. So remember your natural sciences and technology test is tomorrow, and I will put up the link in class tomorrow. Okay, for those of you who can't get it, today is, I think, social sciences. All right. Okay, guys. So are we done? Are we done with drawing and writing down the component as well as the symbol in our books? Can I move on? Okay, just indicate for me when you guys are done. Okay, are we all done? Can you move on? Okay, cool. Right, how to draw a circuit diagram. So this is just a quick activity. Okay, so be referring to figure 5, which is a one cell circuit diagram. All right. Okay, so the cell is the input device. Okay, so we know that. Like we've already said that the cell or the battery is the input device because it provides the energy for the circuit, right? And then the light bulb is the output device. So right now at our stage, right, because we're in grade 6, we're only using the light bulb. Okay, so when you guys go to grade 7, grade 8, you will be required to use a motor or maybe a buzzer. All right, but right now we're just focusing on the light bulb. So the output device is drawn in an it's drawn opposite the input device. Okay, so if we can just look at figure A here, right, figure 5A and figure 5B, you can see that the battery or the cell is on one end and the output device is on the other end, and they are opposite each other. So that is how you should always draw your circuit diagram, right? Then the switch is drawn between the cell and the bulb. Okay, so that is standard. That's how it should always be. That you need to draw the switch between the cell as well as between the bulb. Right. Then, if the switch is closed, the direction of the current can be indicated with an arrow on the diagram. So if we just look at figure B here, then and we see that the figure is the circuit is closed. Here is the arrow, which is showing us the direction of the current, right? Okay, and very much important is that direction of current, of electric current on a circuit diagram is always from positive to negative. Always from positive to negative. Okay, so guys, I'm just going to give you a few minutes to jot this down in your books, then we can continue. Right, welcome to Gello. Guys, let's keep chats to a minimum, all right? Let's keep chats to a minimum. If it's not about class or it's not about the work that we are covering, can we just not discuss it, please? And just indicate for me if I can move on, all right? Or if I should just wait a bit longer. So these are ways in which we should draw a circuit diagram. Okay, no problem, Talia. I will wait. I'll give you 2 more minutes. Okay, so I see Mukwana says they're done. But then this is they're done. Guys, are you just taking screenshots or are you writing the work down? Are you guys taking screenshots or writing the work down? Okay, Ndoro, I see that you are done, and welcome back. Yeah, we're still waiting for Talia. Talia is not yet done. Okay, all right, there we go. Guys, if you take screenshots, do you ever go back to your screenshots and write the work down in your books? Or do you just have a million of screenshots in your phone for every other class? Just use the time to actually write down in your books, guys, because it gets very confusing when you have like thousands of pictures in your phone, and yeah, it becomes very messy. Okay. Right, cool. So this was an indication basically of how we should draw the circuit diagrams, right? And then here we have an indication of how electric current flows. So if you remember from this slide here, the last bullet said the direction of current on a circuit diagram is always from positive to negative, right? So even here on this picture, we can see the direction of current. It is indicated to us from the positive end of the battery to the negative end of the battery, or the cell, as we may call it, or rather as we should call it. Okay, cool. Activity, all right? So I'll need you guys to basically participate in this. And yeah, first question, or rather, let's see what it says. It says, look at figure 3 again and then answer the questions that follow. First question, what are the 3 components of the circuit shown in figure 3A? Rather, this should have been figure 5A, right? Yeah, figure 5A, sorry about that. So we're looking at this top circuit here. What are the 3 components of the circuit shown in figure 5A? Okay. Right, Triasha, I think I pronounced your name correctly. Let's hear what you have to tell us.
Hello, ma'am.
Hi, how are you?
I'm good.
All right.
The 3 components is a light bulb, a light and switch off button, and a circuit.
Okay, so you said a light bulb?
Yeah.
A switch, and what else?
I think the third one is it's a wire. I'm not sure.
You're not sure. Okay, all right. Thank you very much, Triasha.
You're welcome, ma'am.
Awesome. Okay, so let's hear what I think it's pronounced as Cruz. Yes, Cruz. Hi, how are you?
Hi, ma'am.
Hello. What's your name?
I'm using my sister's laptop.
Okay, but what's your name?
Wutu.
Botu.
Yes.
Okay. So Botu, now what are the 3 components that are shown in the circuit in figure 5A?
It's the light bulb,
All
the
right.
switch, and the battery.
Okay, so the light bulb, the switch, as well as the battery. All right, thank you very much, Botu.
Okay, ma'am.
All right, let's take the last hand, or 2 last hands. Yeah.
Yes, ma'am. The three components in figure 3A is the light bulb, the switch, and the battery.
Okay, so the light bulb, the switch, and the battery. Okay, thank you very much, Kia.
Thank you, ma'am.
Okay, let's hear Kamohelo. Okay, Kamohelo, you do need to accept on your side, ne? Right, there we go. Yebo.
Can you hear me?
Yes, I can hear you.
The 3 components is a cell or a battery. There's also the bulb, the light bulb, and there's also the switch.
All right, beautiful. Thank you very much, then. Okay, and last hand, which is Nduvo.
Ma'am, the three components are a battery cell, a switch, and a light bulb.
A battery, cell, okay,
Cell.
a cell switch as well as a light bulb. Okay, beautiful. Thank you very much. Okay, so I think most of us got it correct. We have a cell or a battery, switch, and light bulb. And guys, we have another component, which I get here on this question, they asked for three components, but there is another component which is on the circuit diagram, and I believe we all saw it, and it is the wire. All right, so remember I told you guys that the conducting wire is shown by straight lines. Okay, have straight lines. Okay, so just a question, Jenny. It's not in this activity. How many conducting wires do we have in figure 5A? How many conducting wires do we have in figure 5A? Okay, I see Kamahella's hand is up. Yes,
Ma'am, I
Kamahela?
think we have, ma'am, you hear me?
Sorry?
Ma'am,
Hi.
ma'am,
I
can
can
you hear
hear
me?
you. Yes.
Yes, ma'am. I think there's four components there. I think it's the light bulb, the battery, the
Yes.
electric wire, and also the switch.
The switch, all right, cool. So now my question is, the question that we just did now asked for three components. So now my question is, how many conducting wires can we see in figure A?
I don't know, ma'am.
You don't know? Okay, no problem. Let's see if Botu can help us. All right, thank you very much, Kamahelo. Okay, let's see, Botu.
Hello, ma'am.
Hi.
Hi. I think there are three.
You think there are three, all right, and I think you are correct because we have one wire here, all right, which is connecting the light bulb to the cell, so that is one, and then we also have another wire which is connecting to the switch here, that's two, and from this end as well, that is three, all right, so thank you very much, Botu. All right, so we have three wires, right, conducting wires in figure 3A. Okay, so next question. Is this an open or a closed circuit? How do you know? So this is referring to figure 5A, yeah? We still at figure A. Is this an open or a closed circuit? And how do you know this? Okay, Triasha?
Ma'am, it's a closed circuit because the wire there it's opened, which means the switch is not on. And if that wire there is closed, which means it's on.
Okay, so figure 5A, oh, we muted there, but okay, cool, no problem. Let's hear what Kia has to say. But thank you very much, Triasha, for your answer. Yeah?
Ma'am, I think it's a open circuit
Okay, why?
because the switch there is open.
Okay, thank you very much. And then if the switch is open, what's happening to the current?
Ma'am, the current will flow.
The current will flow. Okay, thank you very much, Kia. Right, so I see
Thank you, ma'am.
Shakira also answered in the group, as well as Talia. Talia said, I think it's an open circuit. Okay, Talia, why do you say it's an open circuit? Shakira also says open circuit. Right, so why do you guys say it's an open circuit? And Gia also said it's an open circuit, and the reason that Gia gave me was that the switch is open. Right, so I need, Adeline also says it's an open circuit, all right? So I need reasons why it's an open circuit. Josie Lee, tell me, why is this figure 5A an open circuit? Right, guys, I need reasons. So why are we saying that figure 5A is an open circuit? And if we're saying it's an open circuit, what happens to the electric current? Okay, Tokello.
Ma'am, I think it's a closed circuit because it's up and no electric current is flowing to the light bulb from the battery.
Okay, so you're saying that it's a closed circuit because the switch is open and there is no current flowing in the circuit.
Yes, ma'am.
All right, thank you very much, Tokello.
You're welcome, ma'am.
Awesome. Okay, so let's see what the answer is. So guys, it's an open circuit, okay? So an easier way to remember this is that an open circuit is one where the switch is off or it's open, right? As you can see here that this thing is open, right? We have a gap in the circuit. And remember, when we have a gap in a circuit, current does not flow. So Tokala, you were correct about the last part where you said that there is no current flowing, okay? But this is an open circuit. So in an open circuit, current does not flow, okay? And the switch is always open or off, all right? So those three factors are very important, that in an open circuit, the switch is open or off, and that current doesn't flow, okay? Okay, last question. What do you need to do before current can flow in this circuit? With regards to what we have just covered, what do you need to do before current can flow in this circuit? Okay, I see your hand is up first.
Thank you, ma'am. What we need for the current to flow is that we switch on the switch.
All right, so we need to close it, right? So it needs to be connected like in figure B.
Yes, ma'am.
All right, thank you very much. Okay, so let's hear what Vutu has to say.
Ma'am, I was gonna say the same thing.
Yeah, you can say it again. What are you gonna say? What are you gonna say?
I was going to say that we're gonna have to close the switch so that the current can flow.
Okay, beautiful. And in which direction does current flow?
Left. I don't know if you're like on the left or right. So I would.
Okay, listen. Is it from positive to negative or from negative to positive?
Is positive to negative.
All right, remember that, né? Don't forget it. Okay, awesome. All right. Okay, so indeed we need to close the switch or put the switch on. All right, so you guys can see circuit diagrams are fairly easy. So even if you build a circuit at home, you can also draw a circuit diagram of the circuit that you have just built. All right. So again, the symbols that we use in circuit diagrams are standard symbols. They're used all over, from engineering to science to electricians, etc. They use the same symbols. Okay, so if you learn them now, then you don't need to relearn them for the next coming grades. Okay. All right, so this cartoon says that's much better. I can definitely draw these easy symbols for circuit diagrams. All right. Okay, so key concepts. This is a summary. An electric circuit is a system for transferring energy. A circuit is complete and unbroken pathway for electricity. A simple circuit is made up of different components, have a source of energy, conductors, as well as a device. All right. And then a circuit can have a switch to turn it on or off. Electric circuits can be drawn as circuit diagrams using symbols. Okay, so I'll give you guys just a minute to jot these key concepts down. Okay, and then I'll just need an indication from you guys if I can move on. You guys are very busy here in the group chat, eh? Like, okay. All right, guys, can I move on? All right, I see yes, yes, done. Okay. Okay, Anne says I should wait a bit. All right, no problem. Let me just wait a minute or two longer. Right, so Anne, if you're done, just indicate for me, okay? If you're done, just say yes or something so that we can move on. Okay, moving right along. Awesome. Okay, cool. Okay, so we're moving on to the next topic. Okay, next topic. This is electrical conductors and insulators. Electrical conductors and insulators. So we are done with electric circuits, and the next topic we're looking at is electrical conductors as well as insulators. Question: what are conductors and insulators? What are conductors and insulators? Okay, Kia.
Thank you, ma'am.
Okay, just hold on. Guys, I am gonna go back and since she's not busy, but you can answer, yes?
Okay, ma'am. Materials that conduct electricity are called electrical conductors. Most metals conduct electricity. Copper is a good electrical conductor. The parts of electrical objects that
Okay,
need
hold
to
on,
let
hold on,
electricity
yeah,
pass through
yeah,
are always made of metal. Yes,
yeah.
ma'am.
Okay, so remember what my
Yes, ma'am.
question asked me? My question was, what is a conductor and an insulator? Okay,
Oh,
so you have covered conductor, and I see you even read an example of a conductor. Now give me an example of an insulator, or rather a definition of an insulator.
materials that do not conduct electricity are called electrical insulators.
All right, beautiful. Thank you very much for that, Kia.
Thank you, ma'am.
Awesome. Okay. Okay, let's hear what Tukello has to say.
Ma'am, a conductor is something that carries wires and lets electricity pass through it.
All right. And then an insulator.
An insulator is an insulator is something that does not allow electric to pass through it.
All right, beautiful. So a conductor allows electricity to pass through, and then an insulator is a material that does not allow electricity to pass through. Okay, thank you, Tukello. Okay, let's hear Talia.
Ma'am,
Mm-hmm.
electric conductor is a material that can go through electricity, and an insulator is a material through which an electric current is not able to travel.
All right, beautiful. Thank you very much. Okay, so let's take the last hand, and it will be Triasha.
Ma'am, a conductor is something electricity that allows us to travel through. Like for example, copper it can travel through, and then
All right, wait,
insulators are
wait. Triasha, start again.
yes.
What is a conductor?
Conductors are is electric material that does allow it to flow. Like for
Okay, so
example, copper.
all right, so a conductor is a material that allows electricity to flow through it.
Yes.
Okay, an example is copper. All right, cool. And then an insulator.
An insulator is an electric material that doesn't allow it to flow. Like for example, plastic doesn't allow, or maybe a coin doesn't allow.
It doesn't allow electricity to flow.
Yes, ma'am.
All right, beautiful. Okay, so remember when you are giving definitions, always say, don't say it doesn't allow it or doesn't allow them, just say exactly what it doesn't allow. For example, if you're going to say an insulator is a material that doesn't allow electricity to flow, call it by its name. All right, it's very important to do that. Okay, so let's get back to the work. A material can either conduct electricity or it cannot conduct electricity. So a conductor is a material that allows electricity to flow through it, right? And then an insulator is a material that does not allow electricity to flow through it. Okay, so here we have the definition for conductor as well as insulator. Then most metals are conductors. For example, we have aluminum, silver, which are good conductors. And you guys also gave me some examples which were copper. Okay, so I think I'll just give you guys a minute here, but I think this was fairly easy. We all knew what a conductor was and what an insulator was. Okay, so just a minute and then I'll be moving on. Okay, Triasha, see your hand.
Sorry, ma'am, if I'm disturbing, but the host disabled the chat because of Josie is busy writing weird stuff. So now people can't answer in the chat box anymore.
Oh, okay, I've noted that, right? But you can raise your hand to give me answers, okay? Or if you have questions, you can raise your hand. Thank you. See, guys, you need to behave. You need to behave so that privileges may not be taken away from you. Anyways, let us continue. Right, so here we have the examples of the good electrical conductors. We have aluminum, we have, this is copper, and that is silver. No, that is graphite, sorry. This is graphite, the last picture is graphite. Right, okay, so we can test whether a material is a good conductor by using them as components or testing them out as components in a circuit. Okay, so instead of copper wire, you can maybe use silver wire, right, to see if indeed silver conducts electricity, or instead of the silver wire, you can probably test out the aluminum or test out the gold or whatever metal that you might have. All right, then silver is the best conductor, meaning that it is a material which makes it the easiest for current to flow through it, but silver is expensive. and that is why silver is hardly used to, or rather it's hardly used in electric circuits. Okay, then gold does not rust, and it is used when high quality contacts are needed. Okay, so gold is also expensive, but it is also hardly used because it's expensive, right? I think I did mention that. Okay. Aluminium is a metal, but it's not a very good conductor. Okay. And our bodies are also good conductors of electricity. Okay. So I think we have noted so far that metals, or most metals, are good conductors of electricity. Can you guys give me an example of a non-metal which is a good conductor of electricity? An example of a non-metal which can be a good conductor of electricity. Okay, Wotu.
Hello, ma'am.
Hi.
I think a circuit doesn't have wires, so I would say circuit.
Okay, no, Wotu. Let's start again. We have mentioned the good electrical conductors, ne?
Yes.
And we mostly said that metals are very good conductors. And my
Yes.
question is, ne, give me an example of a non-metal which is a good conductor of electricity.
Water.
Water. Why is water a good conductor of electricity?
Because if you put electricity on water, it's easy for it to flow.
Wow, interesting. So water conducts electricity, guys. Wow, okay, thank you, Butu. Let me hear what Tokello has to say. Thank you very much, Butu. Wow. Tokello?
Ma'am, we are also non-metal, but then we can still conduct electricity.
Okay, so our bodies are also good conductors of electricity.
Yes, ma'am.
All right, cool, awesome. Okay, so I see most of you guys in the group are saying water. Trish is also asking why water. I also have that question. Yeah, why are you saying water is a good conductor of electricity? Okay, there you go.
Ma'am, why I say water is a good conductor of electricity? The water will flow much better, and I think the electricity would stay in the water for a long time, and you would get shocked.
You will get
if
shocked.
you
So are you
touch that
talking?
water.
Oh, okay. So if you touch water that has electric current, you will get shocked.
Yes.
Oh, interesting. Okay. All right. So I hope
Yes.
you guys agree with Kia. Do you guys agree with Kia? Okay, let's see what Tukella has to say.
And ma'am, the reason why also water, electricity can travel through water, it's because small bits of metal have been traveling in the water without us seeing it.
All right. Okay. So that makes much more sense. If the water is not pure, and the water is mixed with something else, then electricity can, or rather that mixed water can be a conductor for the electricity. All right, so pure water, guys, important to note, pure water cannot conduct electricity, but water which is mixed with salts, all right, or other metals can conduct electricity. For example, salt water, all right? Salt water is a very good conductor of electricity, and our bodies are also good conductors of electricity because the water in our body, it is not pure water, okay? There is salt mixed, we have a whole lot of mixtures, all right, in the water that is present in our body. Okay, very important to know. Okay, and then copper is a very good conductor. Okay, so most conducting wires are used in electric circuits are made of copper. I think Ia mentioned this when they read from their textbook. And then reasons why copper is preferred as a conductor for electrical installations is that copper is a good electrical conductor. It is easy to bend. it is easy to bend it so that it connects well with other components in an electrical circuit. It can be bent a lot of times without breaking. And lastly, it is not expensive. All right. So you guys just have like a, okay, so it seems like time is up. And here we have picture of the different thicknesses of copper wire. Then tomorrow, guys, we're going to look at electrical conductors and insulators. So today we dealt with conductors. Tomorrow we'll look at insulators. Remember, you can go to Snaplify to get yourself the Via Africa Natural Sciences and Technology textbook, as well as the Siavula textbook, and hopefully tomorrow will behave. Woo. I really hope tomorrow will behave. And guys, if you do have any questions, you can send the school an email at stemdigitalschool@africateengeeks.co.za. Thank you very much for joining in class. See you guys tomorrow, and all the best for the assignment or the test that you guys are writing today. Okay. Goodbye, guys.
Ma'am?